Alright, today we're going to continue our talk about quadrilaterals. We're going to talk about three new quadrilaterals. We're going to talk about the rhombus, the rectangle, and the square. Now originally we talked about the parallelogram. The parallelogram had 5 properties that went along with it. As you're going to learn, the rhombus, the rectangle, and the square all have those same properties of a parallelogram. So all of these are types of parallelograms. I'm going to go ahead and write some notes down to show you a little bit of the differences between the types of parallelograms. First, we have a rhombus. A rhombus is a parallelogram with 4 congruent sides. So if we have 4 congruent sides, we can go ahead and tick mark those sides. Next, we have a rectangle. A rectangle is a parallelogram with 4 right angles. So whenever we get a parallelogram, or excuse me, a rectangle, we want to make sure we put the right angles in the corners. This is going to be very important as we go down into future problems. A lot of times when we have a problem dealing with a rectangle, we're going to be dealing with diagonals. A lot of times those diagonals will go ahead and create a triangle with a right angle, where you guys may have to use Pythagorean theorem to go and figure out the different lengths. Last, we have the square. The square is like the super parallelogram. It has all the properties of a parallelogram, a rhombus, and a rectangle. So, a parallelogram with 4 congruent sides and 4 congruent angles. And those 4 congruent angles are right angles. So whenever we see a square, we can go ahead and start tick marking all 4 sides congruent and all 4 angles congruent. Okay, if you remember, back a couple days ago I passed you out a packet that looks like this. It deals with the 5 properties of a parallelogram, so we know automatically that a parallelogram has both sides, both pair of opposite sides are going to be parallel. Okay, we know both pairs of opposite sides are congruent. So these 2 sides are parallel. This side is congruent to this side, top is congruent to the bottom. Both pairs of opposite angles are congruent. So lower left to upper right, upper left to lower right. Consecutive angles, whether they be on the sides here, equal 180, or across the top here, equal 180. Okay, so we call those supplementary angles. And the last, we have 2 diagonals here. If we go draw a line from corner to corner and corner to corner, okay, this diagonal here bisects this one. This diagonal here bisects this one. So moving along now, we're going to go ahead and talk a little bit about how they connect with each other. Okay? Is a square a rectangle? Well, let's think about that. If I go back to my chart, square is on the bottom. Anytime we start on the bottom and move up, then it's going to be always. Anytime we start at an upper level parallelogram and move our way down, it's going to be sometimes. Now the last one, if we have a rectangle and a rhombus, there's no connection there. We see the flow around to the right, we see the flow around to the left. Okay, there's no connection between a rectangle and a rhombus, so that would be never. Be ready, you guys are going to go ahead and use this chart to go ahead and help you solve problems. So we go from a square to a rectangle. A square was at the bottom of the chart, a rectangle was up from it, so that's going to be always. is a rectangle a square? Well, we went back to our chart. A rectangle was in the middle, a square was connected to it on the bottom, so that's going to be sometimes. Is a rhombus a square? Those two were on both sides and never connected. A parallelogram is a rectangle. Well, parallelogram is at the top, rectangle is going down, so that would be sometimes. So we'll scoot it up here a little bit more. Next, what do we know about this? ABCD is a rhombus. What else do we know about ABCD? Well, first of all, we know that opposite sides are congruent. And actually, because it's a rhombus, we can say that all sides are congruent. So right away, we can go ahead and tick mark all four segments. What do we know about opposite angles? Opposite angles are also congruent. So if I go D with an arc, I go the opposite angle B, that gets an arc, A gets 2, C gets 2. Consecutive angles are supplementary. That means if I take any two angles that are consecutive, they're going to be supplementary. So let's say I give D a value of x degrees. I know A is going to be 180 minus x degrees. Because whatever x is going to be for there, that's going to go ahead and equate to 180. So how do we say that? Consecutive angles are supplementary. That's equal 180 degrees. Now, we talked about from before, diagonals. What do? They bisect. Diagonals bisect each other. So in this case, we go ahead and draw in our angles here, our diagonals. If I take this long diagonal here and I cut it in half with segment AC, I know that these two parts of the diagonal are going to be congruent. Same way here, if I take the short one, the long one bisects it. So that'll get 3 tick marks. And next, both pair of opposite sides are parallel. Okay, so if I was going to go here, I could mark this with the arrow and this with the arrow, this with 2 arrows, this side with 2 arrows. Next, going to do a little math talk here. A quadrilateral is a rhombus if and only if it has 4 congruent sides. Remember, that's a property of a rhombus. A quadrilateral is a rectangle if and only if it has 4 right angles. And next we have the square. For a quadrilateral to be a square, if and only if it is a rectangle and a rhombus. So those are basically the notes that we have for today. We're going to go ahead and utilize some of this information to answer a couple questions. So if I look down here, I know I have a rectangle. Right away I know I have 4 right angles. That's what I'll make a little bigger just so I don't cover up the problem that we have. So each of these angles is 90 degrees. So I look at this and I can say 7y plus 6 equals 90 degrees. Now I just go ahead and solve. We subtract the 6 from both sides and we get 84. 7y equals 84. We divide by 7 to get y by itself. And then we go ahead and find out y equals 12. Well, I should be able to plug it in here and get 90. 7 times 12 plus 6. 84 plus 6 equals 90. So I was able to go ahead and check my answer and find out that I was right. Alright, we're going to skip over this one. I'm going to have you guys do this one on your own. We're going to jump up to the next theorem. So the next theorem is going to talk about a parallelogram is a rhombus. And in this case, it's a rhombus if and only if the diagonals are perpendicular. We all remember the symbol for perpendicular, the upside down T. So what that allows us to do is put the box in there. The diagonals are perpendicular to each other. We want to write a little star over here. Look to use PT, Pythagorean theorem, coming back at you again. Alright, next. A parallelogram is a rhombus if and only if each diagonal bisects a pair of opposite angles. So, what do we know from that? Okay, we're going to be dealing with angles here. So let's take this angle, A. Each side of it will give one arc. C will give one arc to each side. D will give two arcs to each side. Notice I'm offsetting them. So what that means is this angle is congruent to this angle, and this angle is congruent to that angle up there, and this angle. These four angles are congruent on this part. These four angles are congruent on that part. So let's say I gave them a value. Let's say here, since we know we already have a right angle in the middle, if this was 30, this one would have to be 60 to equal 180. Well, since these two are congruent, this one's going to be 60, then this one would have to be 30. Same thing goes for the rest of them. 30, 60, 60, 30. So we know these diagonals bisect these opposite angles. So angle B, or angle ABC, would be normally 120 degrees, but this gets bisected by it. Angle BCD is 60 degrees, but it got bisected. Now we're going to talk a little bit about the rectangle. Okay, a parallelogram is a rectangle if and only if the diagonals are congruent. So what does that mean? If we look over here, here's one diagonal, segment AC. That's going to be congruent to segment BD. So, a couple ways I could do this. The easiest way possible is to go ahead and tick mark each portion of the diagonal. And we just have to remember that BD is congruent to AC like we wrote over here. Once again, we have right angles because it is a rectangle. So we could be looking to use PT, Pythagorean theorem. Okay, with that we're going to go ahead and stop here. We'll try to answer the other questions right away in class. If you have any questions, come see me. And that is all.